All right, so this is the key to equations worksheet 5, and that's the one where you had to solve literal equations. Now, some of these equations I have here are made up equations. They're really not, in other words, they're really not formulas. Um, so some of them are just equations that were made up just to make sure that you know how to solve for a particular variable. Um, okay, so remember, literal equation is an equation that has at least that has more than one variable. So notice this equation has more than one variable and so on. All right. Now, not all of those are considered formulas like you would have seen in geometry or like uh, Pythagorean's theorem or things like that. Okay, so let's look at number one. So number one, you have a equals 2 times pi times r squared plus 2 times pi times r times 8. So remember, if you don't see an operation, it's understood to be multiplication. And you want to solve for the variable h. Now, if you look at all of these terms, you have this term, you have this term here, and you have this term here. So remember, terms are separated in this case by either addition or subtraction. In this case, it's addition. So, and on the other side, you just have one monomial, so you consider that a term. But on this side, that's the only place where you see the variable h, and it's only in this term. Okay? So this is the only term on the other side, on the right side, that has a variable h. So since this is a term itself, so let's bring this term to the other side first. All right, so we're going to isolate the term that has the variable h. So get this by itself. All right, so right now, this term, see the coefficient is a negative 2? I'm sorry, positive 2. So let's go ahead and subtract 2 pi r squared. And that kind of makes sense, right? So if I want to get rid of this term right here, I've got to think about, well, what do I need to do to both sides to get this to be a 0? And so 2 subtract 2, the coefficients, if you look at this in terms of a coefficient, although pi is a number, you could think of this as a coefficient being 2 pi. All right, it doesn't matter for our purposes right now, but you're going to subtract 2 pi r squared from both sides, just like this. All right, and then you can combine like terms. Now these are not like terms, so what you have to do here on the left side, those are not like terms. So what you have to do is you're going to have to write it horizontally like this. You have to say a subtract 2 pi r squared. And make sure your exponents look like exponents and so on. Your variables. So in other words, if this is a capital A, don't make this a lowercase a, all right, because those are not the same variable. So remember, mathematically, you have to write things correctly. And then that's going to equal, and then this is 0, and then 0 plus 2 pi RH is 2 pi RH. So that's where we're at. So now notice that the variable h is only in this term, and when I look at that variable h, it's being multiplied right here by 2 pi r. So think of 2 pi r as being a coefficient. So it's kind of like saying when I had this 3x equal 8, then if I'm solving for the variable x and that variable x is being multiplied by 3, I'm going to think of 3 as the coefficient. So I'm going to divide both sides by that coefficient. Okay, same thing here. So we're going to think of the coefficient of h being 2 times pi times r. So then I'm going to divide both sides by 2 pi r, just like this. And what you do to one side, you do to the other. And make sure that all of this is in that numerator. Okay, all of that left-hand side is in that numerator. And that's going to also be divided by 2 pi r. And now reducing 2 pi r divided by 2 pi r is 1. And then 1 times h is h. So I get h equals a minus pi r squared divided by, 2, a minus 2 pi r squared divided by 2 pi r. And there's your answer. Okay, now be careful. Now that's the way I would leave it. Now be careful. Now some students will try and go further, but you got to be careful you try and go further because if you go further and you make a mathematical error, you don't get full credit. All right, so everything you write has to be scored. So what some students do, they make the mistake. They see a 2 pi here and a 2 pi here, and they want to cancel those. You can't do that because if you just cancel these right here, you forget about the fact that a is also being divided by 2 pi r. So when you cancel, it's no longer there. So in other words, if you do this right here, just like this, then you're going to say it's going to be a minus r squared divided by r, and that's not true because a is also being divided by 2 pi r, and you forgot about the fact that there's no 2 pi r here. I mean, no 2 pi here. All right, so be careful. Now, what some students will do, and I'll go ahead and show you. Now, that's the way I would leave it, but what some students will do is this. They'll go ahead. Let me go ahead and rewrite this right here. They'll say a minus 2 pi r squared divided by 2 pi r equals h. So they'll say h equal, they'll go further. Now be careful if you go further. Any error you make, I cannot give you full credit any longer. So I have two terms being divided by this monomial. So you have to rewrite this as a divided by 2 pi r minus 2 pi r squared divided by 2 pi r. Okay? And then remember our discussion we had a while ago. So if you just cancel these out right here like I did, you're forgetting the fact that a is also being divided by 2 pi r. Now if you go further like you did here, then you're going to see, all right, well I can divide these two pi's, which you can, and then I'm going to get a divided by 2 pi r minus r squared divided by r equal h. But then you have to realize, well, I have two factors of r here and only one factor of r here, so I can reduce that further, right? So in other words, r goes into r one time, r goes into r squared just r times. And so then your answer, if you were to go further, then your answer would be a divided by 2 pi r minus r. That would have been the answer if you had gone further. But I would have just stopped here. Just leave it as one fraction, just like I did. All right, and you're fine. But remember, when you go further, what you have has to be scored. Everything you write has to be mathematically correct. All right, number 2. So number 2, we have this literal equation, m, lowercase m, divided by x, equal p minus n, and you want to solve for x. All right, now this time I want you to notice I have a fraction, and in fact that denominator is the variable I'm looking for. I want to get by itself. All right, so just like in previous problems you've done when solving linear equations, you want to clear those fractions. So what we're going to do is we're going to find the LCD. So the LCD is, so when you're finding the LCD, you got to look at all your denominators. So this denominator is an x, and I can think of p as being p divided by 1 and n divided by 1. So my least common denominator is going to be that x. So if I want to clear those denominators, then I've got to multiply both sides by the factors that are in those denominators. And even though those are ones here, the only thing I see that really needs to be placed in the LCD is the variable x. So x is going to be your least common denominator. Now what you can do next is you're going to multiply both sides by that by that least common denominator. So then you're going to say times x, and then all of this has to be multiplied by x. So make sure you put that in parentheses, because all of that right-hand side, which has two terms, has to be multiplied by x. And then reducing here, I've now cleared the fraction. So what I now have is m equals x times p minus n. Now, at that point, remember you're solving for x, right? At that point, don't distribute. Just think about what you have. Think about what you have. You have x times p minus n. And if I want to rewrite it, I can. It may make it a little bit easier for you to think about it. Maybe, maybe not. But remember, multiplication is commutative. The order in which you multiply does not matter. So x times p minus n is the same as p minus n times x, right? And so if I'm trying to solve for x, notice I'm multiplying x by p minus n. The opposite of multiplication is division. So then what we're going to do is, I'm going to go ahead and just rewrite this over. Then what we're going to do is we're going to divide both sides by p minus n. And I'm not going to put parentheses there because I know that p minus n divided by p minus n is 1. 1 times x is x, equal, and then m divided by p minus n. And there, that would be your answer. Okay? See, if you had distributed, it would have made things a little bit more difficult for you. Okay, watch. And that's what students do. Students, when they see parentheses, they want to right away think of the distributive property. Well, you got to be careful. Sometimes you don't need to use the distributive property in many situations. Now, most times when solving equations, you do, but not in this case. Because watch, if you had done that, you would have had this situation. So distribute the x, you would have said m equals x times p is p times x, and then x times a negative n is a negative nx. But then you would have said, well, how am I going to get x by itself? Well, you got to remember the idea of factoring. So I noticed that if I look at those two terms, which have the variable x I'm looking for, I'm going to have to use the idea of factoring. Both of those terms contain x. So the greatest common factor, remember when you dealt with factoring, you talked about the greatest common factor. So the greatest common factor of these two terms is x. So I have to factor out an x. So m equals x times p minus n, and you're back to where you were earlier. All right. So think about what you're trying to solve for and the most efficient way of getting there. All right. So that was number 2. So let's look at number 3. Number 3, we have 1 divided by a minus 1 divided by b equals 1 divided by c. And you want to solve for b. Now notice I have fractions again, but this time, like versus the previous problem, the only factor in that denominator, in all those denominators other than 1's, was x. So notice I had the LCD just being x. Whereas over here, every denominator has a factor that's distinct. This is a factor of a, this is a factor of b, this is a factor of c. So when you find your least common denominator, every factor you see has to be there. Now remember, the least common denominator is a product of all those factors. So you have to say a times b times c. So all this has to be multiplication, not addition, not commas, multiplication. So remember, the least common denominator is a product of all of these factors. All right, and you have to be a little bit strategic at some point also, because then you have to say, well, how many factors can I put here? All right, so you want to put the least. That will help you clear those fractions. All right, so now I'm going to multiply both sides by the least common denominator. Notice that the left-hand side has 2 fractions. I'm going to put that in brackets. So 1 divided by a minus 1 divided by b equals, and then 1 divided by c. And then I'm going to multiply both sides by a times b times c. A times b times c. And now I'm going to distribute. So I get the least common denominator, a, b, c, times the first fraction, minus the least common denominator, a times b times c, times that second fraction, equal, I'm just going to go ahead and rewrite this over, 1 divided by c times a times b times c. And now I'm going to clear those denominators. So these a's divide out, you get factors of 1's in their place. These b's divide out, you get factors of 1's in their place. And then these c's divide out, you get factors of 1's in their place. So if you're doing this correctly, when you multiply both sides by the LCD, you should be able to, at this point, reduce properly. You want these to be factors of 1's in the denominators. And now remember, all this is multiplication. 1 times b times c times 1 is just bc. Subtract. A times 1 times c times 1 is just ac. Equal. And then over here, 1 times a times b times 1 is ab. All right. Now, look at what I want to solve for. I want to solve for b. Notice I have 3 terms. 1, 2, 3. 2 of those terms have the variable I'm looking for. this term has b, and this term has b. So what you want to do is you want to bring every term that has the variable you're looking for to one side, and all the terms that don't have the variable I'm looking for to the other side. So since this term does not have the variable b, I'm going to leave it by itself on the left side. So I want to bring this term to the other side. So subtracting BC is going to help, because BC subtract BC is 0. That's what you wanted. But what I do to one side, I have to do to the other. And so now what I have, 0 subtract AC, which is a negative AC, equal AB minus BC. Okay, those are not like terms, because this has the variable A, this has the variable C. So those terms don't have the same variables in them. So those are not like terms. So that's all you can do for right now. Now you want to solve for B. So remember our previous problem when we got to this point right here. Let me do it this way. When we got to this point right here, remember that? So these two terms have the variable I'm looking for. So what I have to do is use the idea of factoring. And since those two terms have that factor I'm looking for, have that variable I'm looking for, I'm going to use the idea of that greatest common factor. Same thing here. Look at what you have. I have two terms. This term has b, this term has b, so I'm going to factor out that b. So I have negative AC equals b times, now be careful here, that's going to be b times a is ab, using the idea of the distributive property. Think about this. Subtract b times c is bc. So when I factor out the greatest common factor, I'm left with this. Just like when I did this one here. Okay, so this right here now looks like this. So to get the variable x I'm looking for, I'm going to have to divide by this coefficient p minus n. All right, because this is multiplication, the opposite of multiplication is division. So to get b by itself, right now I'm multiplying b by a minus c. Let me go ahead and just rewrite this over. And so the opposite of multiplication is division. So I'm going to divide both sides by a minus c. A minus c. And so now these a minus c's divide out, you're left with 1s, and b times 1 is b, equal a negative ac divided by a minus c. And just leave it like that. All right, so that's it. There's your answer. Now don't be careful, just like our discussion earlier, you cannot divide out those a's, all right, because this is a monomial, whereas this is a binomial, okay? So this a is not a factor. The a minus c is a factor. A is part of a binomial, so don't distribute. You have to, and that is a mistake people make, and you got to figure out why it is that you keep thinking that you can cancel these out when you can't in this case. See, a is not a factor. The a minus c is a factor. So if you had an a minus c up here and an a minus c, then you could factor, but you cannot do that here. Same thing here. You cannot cancel out these c's, because even though c is a factor of the numerator, because that's a product, c is not a factor of the denominator because it's part of a subtraction here. All right. Anyway, so that is your answer. All right, so that was number 3. All right, let's look at number 4. I'm going to put number 4 right here. So number 4, we have capital L equals A times 1 plus CT. Okay? All right, so capital L equals A times 1 plus CT, and you want to solve for C. All right, so notice the only place I see t is right here, but it's inside a parentheses that's being multiplied by a. So the first thing I need to do is to distribute that a. Now that's one approach. Okay, so let's go ahead and do that. Let's go ahead and distribute that a, and then we'll do it a different way because probably some of you did that. So let's go ahead and distribute that a. So I'm going to write this as approach 1. All right, so distributing the a, we get L equals a times 1 is a, plus, and then a times CT is ACT. Okay? So that's where I'm at. Now the only term, now notice I have 3 terms, 1, 2, 3. Remember, terms are separated by addition or subtraction. So that's why I said that these were two terms here. So consider this a factor. The denominator has one factor, a minus c. But notice that on the left-hand side, on the right-hand side rather, this is the only term that has a variable c right here. Okay? Now, what some students may do to help them is this. Remember, multiplication is commutative, and all this right here that I'm circling, a times c times t, is multiplication. So the order in which I multiplied this does not matter. So a times c times t is the same thing as saying a times t times c, right? And the reason I'm doing that is for you to notice at some point that we're going to get c by itself, you would have to divide both sides by that coefficient at. But first of all, let's go ahead and bring this term to the other side first. So I'm subtract a from both sides. So I get L minus a, capital L minus a. Make sure you're consistent with the variable notation. L minus a, lowercase a, equals, this is 0, a times t times c. And then all I need to do now is to get c by itself. Right now, I'm multiplying by, at, right? So the opposite, let me go ahead and just write it over. So the opposite is to divide both sides by at. And so when I do that, these at's divide out, because all those are factors, a times t times c, a times t. All right? So there you can reduce. Remember, here you could not divide out those a's. Here you can, because these are all factors. Factors are separated by multiplication. A times t times c, a times t. And so therefore, c equals L minus a divided by at, and there's your answer. Okay? All right, don't make the mistake now and cancel out these a's, because this a is not a factor. This a is a factor of the denominator because it's a product, a times t, but a here is not a factor of the numerator. It's part of a factor, L minus a. All right, now at that point, what you want to do is this. So let me show you the approach number 2. Well, there's your answer. All right, now approach number 2 would be this, that some of you would have taken. And it's possible you did that. So let me go ahead and rewrite it over. L equals a times 1 plus ct, and you want to solve for c. All right, so what some students did was this. They said, well, instead of distributing the a, since I'm solving for c, and c is inside that parentheses, and that parentheses is being multiplied by a, I'm going to go ahead and divide both sides by a, and that is perfectly fine. So let me go ahead and rewrite it over, just to show you what would happen. So I'm going to divide both sides by a, and so now these a's divide out, because those are factors. This a is a factor of the numerator, this a is a factor of the denominator, and so I get L divided by a equals 1 plus ct. Okay? Now at that point, you want to, remember, you're trying to get c. So this term is the only one that has c in it, so you need to get rid of this term. So you're going to subtract 1 from both sides. So I have L divided by a minus 1 equal ct. Now this is where it becomes a little bit more complicated. This is more, when you look at the answers, this is the one that we would prefer you write it as just a rational expression that looks like a rational expression. Watch what happens when you do this one. So here, to get c by itself, right now, let me go ahead and rewrite it over. You have L divided by a minus 1 equals ct. So here, when you get c by itself, you have to multiply both sides. Right now, you're multiplying by t, right? So the opposite of multiplying by t is to divide by t, just like this. And therefore, the t's divide out. And you get c equal L divided by a minus 1. All of that's being divided by t. And at this point, I would give you credit if you left it like this, although, and I'll show you, although the problem is that this is a complex fraction. So you have fractions being divided by other fractions. So you're going to learn in a future section that you want to simplify this as much as possible. And let me just show you real quick how to do that. just so you'll have an idea of, how to make this look a little bit better. So I have the left-hand side, which is L divided by A minus 1, all divided by T. Okay, now here's the way I would do this based on something that you already know. So I know that I have that my denominator here is a monomial. So I can take this term in the numerator, L divided by A, and divide by T. And then subtract and take this term in the numerator and divide by T. All right, so this becomes this. Then we remember the fact, and let's see if you remember this, then we remember the fact that if I had something like 2/3 divided by, let's say, 5/7, so when I had a fraction divided by a fraction, then to simplify this, I could think of this division right here. You want to change this to a multiplication problem. So this becomes 2/3 times the reciprocal of 5/7, which is 7/5, and then reduce if you can. In this case, I cannot, so this will be 14 divided by, and then 3 times 5 is 15. Same idea here. You have L divided by A divided by T. So that right here means the same thing as L divided by A times the reciprocal of T, which is 1 over T. And then subtract 1 over T. And so then I get L times 1 is L, and then the denominator is AT minus 1 divided by T. And then you can leave it like this. That would be C. So notice, just to show you, and there are multiple ways you can keep on with this. You can go further with this, and at some point you can make this right here look like this. All right, and so notice this right here looks a little bit better than that. But let me show you. Some of you may say, well, how can you make this look like this? All right, so let's just show you that. And so to do that, to make that look like this is what you need to do. So you have L divided by AT minus 1 divided by T. So you got to find the least common denominator of these two fractions. So the least common denominator is going to be AT. So every factor you see has to be in the LCD. So A is a factor, I've got to put it. T is a factor, so I need a T. So there's your LCD. Then you're going to write two fractions with that least common denominator. And so now you're going to write equivalent fractions. Okay, so notice that this denominator is AT, this denominator is AT. So L divided by AT is the same as L divided by AT. Now right here, this is a T, this is AT. So what I got to do is I've got to multiply this denominator by A because I need an AT. But what I do to the numerator, I have to do to the, what I do to the denominator, I have to do to the numerator. So now 1 times A becomes A. So 1 divided by T is equivalent to A divided by AT, which makes sense because if I reduce the A's, it becomes 1 over T, which is what I had. And now I have two fractions. I have two fractions with the same denominator, so I can write this as one fraction. And it's going to be the numerator minus, this numerator minus this numerator. So L minus A, and that is what you see here. All right. So just some ideas of what to do. But approach number 1, this is the better answer. If you did it this way, which probably some of you did, you would have gotten to this point, and then you would have probably said, well, that looks kind of bad, right? But if you left it like that, I would have given you credit for it. But yeah, it's not as nice as this one is. So you do, at some point, want to go further. All right, so that was number 4. All right, now let's look at number 5. All right, so this is number 5. Number 5, we have 3x plus 7y is equal to 4, and you want to solve for y. All right, so in a future section, not too long from now, you're going to have to deal with graphs, with graphing lines and so on. And so one of the things you're going to learn is the idea of slope and y-intercept. And so when you have a linear equation, which is what this is, because if you look at it, you have x to the first, y to the first. When you have a linear equation, you get y by itself, you can easily find the slope and the y-intercept. So that's the idea here. So this is really practice for something coming up. But to get y by itself, notice that this is the only term with the variable y. This does not. So I'm going to bring this term to the other side. So I'm going to subtract 3x from both sides. And so when I do that, I get this is 0. 0 plus 7y is 7y equal, and I'm going to go ahead and it does not matter. Some of you could have said 4 minus 3x, and some of you could have said negative 3x plus 4. So I'm just going to write it as negative 3x plus 4. And then one more step and you're done. So this is going to be an easy one compared to number 4. So to get y by itself, right now I'm multiplying y by 7, so the opposite is to divide by 7, right? And so 7 divided by 7 is 1, so I get 1 times y is y, equal negative 3x plus 4 divided by 7. And there's your answer. Now, some of you could have gone further. So remember, when you go further, be careful what you write has to be graded. So if you go further, you see this is a monomial. So I can take each of those terms and I could divide by that monomial. So in other words, this right here can become negative 3x divided by 7 plus 4 divided by 7. All right, so either one of those is fine. All right, and that's it. So that is, I believe, the key to Equations Worksheet 5.